right, hello again, and we have quite a few more people in here, so we can get rolling with this without further delay. Thank you, everyone, again for taking time out of your day to come to this month's Dr. Sound Academy. Jumping off where we left off in 2024, we'll be looking again at the basics of audio systems. This month, focusing on speaker considerations. So, presented or with me today, I have Isaiah Vernon. Some of you may know him from one of our or a few of our webinars last year. He'll be going over the ins and outs of speaker or audio systems, focusing on types of speakers, when to use them, where to use them, and what to keep in mind. Without further ado, let us begin.
Quick overview for today. We are going to go over the types of speakers, spaces and use cases, the environmental considerations, and the technical considerations. Alright, the types of speakers that we'll go over today will be horn speakers, design speakers, conventional speakers, and array/line arrays. The first type of speaker we're going to go over today is the horn speakers. The horn speakers are designed to deliver exceptional sound quality and power for a wide range of applications. These types of speakers are built for intelligibility and as such excel in public address and announcement systems. Horns are built to withstand harsh conditions and unforgiving environments. Many models feature weatherproof construction and shock-resistant design. With a wide frequency range response and high sensitivity, they ensure clear sound in noisy environments. TOA horn speakers offer excellent value for both indoor and outdoor uses. So some of our horns will be the CS series wide range horns, the SC horns, the TC horns, and the TU horns. Now let's dive into what we call design speakers, a broad category rather than a strict definition. At TOA, design speakers are all about striking the perfect balance between aesthetics and performance. Our pendant and projection speakers are the standout models in this category, but there are several others worth mentioning. These speakers serve both communication and ambience purpose, seemingly bleeding into architectural and interior designs. Typically available in neutral colors, many models are also repaintable, offering flexibility and customization. The TOA design speakers that we have can be the BS series wall mount speakers, the PE series pendant speakers, the PJ series projection speakers, and the H series interior design speakers. What are conventional speakers? I'm sure most of you are already familiar with the AV world, so we'll keep this section brief. Conventional speakers, the broadest category in today's webinar, are known for their omnidirectional sound, meaning they spread sound waves outwards from the speaker itself. The TOA conventional speakers. We have the F-Block series speakers, the F-series ceiling speakers, and the PC series ceiling speakers. What are array speakers? A line array is a group of omnidirectional speakers arranged in a straight line. These speakers are placed close together to work in sync to create clear, focused sound. Line arrays are great for long-distance sound projections because they have better vertical coverage and more concentrated sound waves compared to regular speakers. The longer the array, the better the sound control, especially for deeper tones, allowing you to direct sound exactly where you need it instead of relying on the building shape. Some line arrays, like our Type C, are modular, meaning they can adjust for both small and large installations. Other types of arrays. Coaxial array speakers combine a tweeter and woofer into one unit, making them very different from line arrays. While coax arrays are single-unit speakers designed for focused sound, line arrays use multiple speakers working together in a row. Variable dispersion arrays take things a step further by letting you adjust the sound direction, so you can fine-tune this setup based on your space. This idea is similar to modular design, where you can customize the system to fit your exact needs. TOA array speakers are the line array type C, H, and S, HX7s, HX5, and the HS series coaxial array. Conventional versus array speakers. Think of a conventional speaker like a light bulb. It spreads sound in all directions, kind of like how a light bulb lights up a room. Design speakers work more conventional than array speakers, meaning they're focused on bleeding into the space while still delivering great sound. A line array works more like a spotlight, focusing sound in a specific direction based on its setup. Horn speakers, including horn arrays, are closer to arrays than conventional speakers, meaning they project sound more precisely and powerfully. What to use and when. There are many types of speakers for commercial sound systems, but which one is best for your needs? Ceiling speakers, great for background music and announcements in schools, offices, and retail, ideal when function matters most. Wall mount speakers, similarly to ceiling speakers, but offer more style options, while still being great for music and announcements. Arrays, best for large spaces needing focused sound, like warehouse and house of worship. Horn speakers designed for outdoor use, mainly for announcements and communications in big open areas. Factors to take into account. When setting up a sound system, spatial factors play a big role. Ceiling height being one of those factors. High ceilings can cause sound to disappear more, requiring stronger and more directional speakers. Rooms versus open spaces. Enclosed rooms help contain sound, making smaller speakers effective. Open spaces need arrays or horn speakers to direct sound more where it's needed. Obstacles, walls, furniture, and layout affect sound reflection and absorption, impacting speaker placement. Choosing the right speakers depends on these factors to ensure clear and even coverage. Distance is another key consideration related to space, as sound loses power over long distances and as such requires high levels of amplification and excellent pattern control to produce adequate volumes throughout the space. Factors to take into account. For clear sound, choosing the right speaker is key, but placement matters too. Will there be ceiling, wall-mounted speakers, or flung? What about brackets, subwoofers, and dispersion angles? The space itself affects acoustics. High ceilings, hard walls, and obstructions can cause reflections. The best sound system considers all of these factors for the best fit. Factors to take into account. It's important to match the sound level to the space. Too much or too little can be a problem. Consider the ambient noise. Is it consistent or does it change a lot? This helps ensure clear and balanced sound. The goal of any sound system is the same: clear, balanced audio for announcements and music across the space. But in places like stadiums, it's not just about hearing the sound, you should feel it too. This is where subwoofers come in. While we haven't covered them yet, placement and usage matters. Subs balance the sound spectrum and create a fuller, more powerful audio experience. We've asked a lot of questions. Now let's look at the solution. Decibels make sound levels easier to measure, ranging from 0 dB, which is barely audible, to 140 dB, which is dangerously loud. A 3 dB change is just noticeable. A 10 dB increase sounds twice as loud. And for clear announcements, aim for at least 10 dB above ambient noise. Now let's talk about speaker sensitivity. This tells us how effectively a speaker produces sound. Most manufacturers, including TOA, measure sensitivity using 1 meter using 1 watt of power. A higher sensitivity means less amplifier power is needed per speaker. We also need to consider power and volume, the SPL. Every time we double the power, the sound level increases by 3 dB. For example, at 1 watt, we are at 90 dB. At 2 watts, we'll be at 93 dB. If we're at 4 watts, we go to 96 dB, 8 watts, 99 dB. This helps ensure the right amplifier power for the best coverage. As we move further from the speaker, sound level decreases, but by how much? For conventional speakers, volume drops by 6 dB every time the distance doubles. Meaning, for example, 1 meter, you're at 90 dB, 2 meters, now you're at 84 dB, 4 meters, 78 dB, and now if you go to 8 meters, you're at 72 dB. For line arrays, the drop is only 3 dB per doubling distance, making them great for long distance sound coverage. Environmental considerations. So looking at the physical factors that affect the effectiveness of your sound system, the environment itself can pose a lot of challenge to the design system. Things to think about are the temperature and humidity, weatherproofing, and obstructions or external influences. For outdoor sound systems, speakers must handle the elements. That's why IP ratings are important. The IP codes show how well a speaker resists water and dust, a key feature when designing an outdoor system built to last. Some systems face direct contact with water, requiring extra protection. Our outdoor speakers are designed to handle this, with ratings like IPX2, splash resistant, or IPX5, jet resistant like from a hose. Many of our water protection models include WP in their names, a common feature in TOA products. Lastly, temperature and humidity matter for both indoor and outdoor speakers. Every product has an operational range, but fluctuations within that range can affect sound. Colder air is denser, humidity changes sound travel, and rainfall adds ambient noise, all factors to consider for clear, constant audio. Technical considerations, reverberation, speech intelligibility, sound delay, and pre-planning and design services. First, let's talk about reverberation. But first, what is reverberation? The word comes from medieval Latin reverberans, meaning to bounce back or rebound. In sound, it refers to echoes and reflections that affect how we hear audio in a space. Here's a detailed infographic showing how reverb impacts sound, for better or worse. Reverberation sound is a collection of reflected sounds in a space, like an auditorium, affecting how we hear sound. Where is reverb common? While reverb can be encountered in all sorts of large-scale facilities, here in TOA we primarily encounter reverberation in large halls, and gymnasium projects. Other areas that commonly face reverb include factories, warehouses, and hall events. Reverberation can sometimes be a good thing. Musicians often prefer it because it adds richness and depth in their sound. But for speakers or lecturers, too much reverberation hurts speech clarity, making it distracting rather than helpful. To control reverb, we go back to space and speaker setup. Direct the sound to the audience with a proper PA system. Use speaker angles like line arrays for better focus. Limit bass since low frequencies are harder to control. Acoustic treatments like panels, bass traps, and ceiling clouds help reduce reflections in certain spaces. When choosing speakers, it's important to control sound dispersion to avoid unwanted reflections. Walls, ceilings, and floors can reflect sound, especially with non-directional speakers. Minimize reflections early with sound-absorbing materials in walls and ceilings. Use directional speakers like line arrays to focus sound and avoid sidewalls dispersion. Powerful speakers help cover long distance more effectively. While this webinar focuses on speakers, a digital matrix or processor can help reduce reverberation and resonance. Now let's focus on line arrays and how sync drive technology improves sound quality. Sync drive keeps sound waves in phase, creating an ideal linear sound source. This results in clear, high-frequency sound with minimal interference. Speakers with sync drive technology includes the HX7s, the SRD, the SRS, the SRH, and the SRC array speakers. Now let's move to speech intelligibility. How clear people hear speeches or announcements. In places like churches, gyms, stadiums, or factories, sound clarity often suffers. This happens when the original sound is interfered by reflections or background noises, making it harder for listeners to understand. High speech intelligibility isn't just about sound quality, it's also crucial for safety and emergency messages. It measures using STIPA, Speech Transmission Index for public address systems, which gauges how well speech can be understood. For compliance and safety, a system should reach at least 0.55 on the STI scale, though higher is always better. A system's frequency response affects its sound balance. Low frequencies create deep bass, high frequencies create sharper sounds, and clear speeches come from a well-balanced mix. Listed here are typical sound pressure levels for varieties types of systems. The SPL meter was set to A-rated for slow response. Systems to be at least 10 dB above the background noise level to achieve a good signal to noise ratio. Let's go over some key terms related to A weighting on an SPL meter. A weighting and A frequency weighting adjust sound measurements to match human hearing sensitivity, covering 20 Hz to 20 kHz. It's the most commonly used standard. C weighted focuses more on low-level sounds and measures impulse noises, with nearly a flat response between 31.5 Hz and 8 kHz. Now Z-weighted, a flat, unweighted response from 8 Hz to 20 kHz, representing the actual sound without adjustments for human hearing. Audio delay is a key factor in sound system designs, especially when using multiple speakers in a venue. It also affects stage layouts, microphone placements, and speaker designs. But what is sound delay? Since sound takes time to travel, you sometimes hear things after they happen. A simple example is lightning and thunder. We see the lightning instantly, but the thunder takes longer to reach us. A physical solution to sound delay is designing the system to minimize its impact on the audience. As shown in the slide, optimal speakers and subwoofer placement ensures even directed coverage across the venue. This creates a uniform listening experience for everyone in the stands. Mixers play a big role in optimizing a sound system, so let's take a quick detour to discuss them. Since mixers control the signals sent to speakers, they directly impact sound quality. Using DSP software like our M880, users can add small delays to sync their sound across different speakers, ensuring the audience hears a full, clear sound with no echo. Here is another example of a GUI that allows users to tweak the configuration to their heart's content, as shown in these photos. And of course, we're here to help with all things sound. Our technical support team is available throughout the design process and beyond. Many of you already know what we do, but if you have any questions about our capabilities, feel free to ask or visit our website for more info.
Dr. Sound.